Hey guys, today I want to make a video on how to, I want to start a series on how to make a game like Dwarf Fortress. That's been one of my favorites lately. I know it's been out for forever, but that's what I've been playing. So the first thing they ask you to do is gather wood. So so you can create a craftsman's bench. So I'm just gonna start there and work my way forward. Basically, today what I'm gonna show you is how to do raycasting and how to create basically a pathfinder to grab this log. Now, as you see, my character is shaking a little bit along this path, and that's just because it's saying, oh, well, what's the normal? And the normal is bouncing between the X and the Y because the distance from here, the X and the Y distance. So like if you break this into a vector, so the Y would be here. Let me take out, well, actually I don't have access to snipping tool at the moment, but this distance and this distance is equal, so it's kind of the normal is jumping between y and x, and so he does this zigzag pattern. And if you want to fix that, you can write an algorithm. It takes a little bit of time to write one of those, at least for me, the way I think it should be done. But you can say, well, if it's in whatever, within 10 or less of the x and the y being equal, you could say, oh, well, y always takes priority over x or one or the other, and that will smooth that out. Anyways, I'm going to create a new project so we can do this from the beginning. I had a pathfinding with collisions as well, but there seems to be some cases where that doesn't work, so I need to fix that before I make a full video on that. So we're going to open up our main collection, and we'll also create a new folder, and we'll call this world. And under world, we need to have two objects. One's going to be a tile source, and one's going to be a tile map. Now we have our tile source and tile map. We need a PNG of a tile map for our tile source. So I went online. I downloaded this off itch.io Grass Plus. It's really nice. Has a ton of textures, and so I'm gonna bring that into Defold. So I'm going to show in desktop, and then I'm gonna open up another folder, File Explorer. Just go to my downloads. I've recently downloaded it, so if I can actually, 1 second. All right, I'm gonna move that into my world folder. You can just close the world folder. I'll close this because we're gonna need it later. And then we'll go to our tile source, and we're going to attach our grass plus PNG to our tile source. As you can see, it's very nice. And yeah, that will be nice. And so we're going to create a tile map, and we'll go to layer one. We'll go attach the tile source, and we'll go to layer one. And if you press spacebar, you can view your whole tile source. And so we're just gonna pick some grass. I'll pick something nice, and we can just paint this out. Doesn't really matter. It doesn't have to be perfect. We'll fix it later, or you can fix it later after the video's over. Just paint this in. And now we almost have our tile map, which is just going to be our background to make things look all nice and everything. And then we'll go to our main collection, which this is our main world. And in here we will add our uh, we'll add a game object, and then to our game object we'll just add a game object file. No, sorry. Add a component file, world tile map. And now we have this big tile map in our world. We'll just name this world as well. We'll just stick with consistency. You can only have in your collection, you can only have one thing named the same. of the same type, essentially. So if we make another game object, it can't be called world. So now we have our world. Now we need two more things. We need our character, and we need a um, and we need uh, basically a sprite for our stump. So I'm gonna make one more new folder. We'll just call this characters. Create that folder. We'll show in desktop, and then I'll open up my Paint app. And real quick, I'm just going to control scroll in. I have 100 by 100 pixels set up. You can change it to 16 by 16 if you prefer that format, or whatever size. It doesn't matter. You can always scale it in game. And so I'm just going to draw, and I'll just go, this is my guy. This will be my character. Go to layers, and then you want to just hide the back layer before you export it. And then I'll file save and go to downloads. And we'll call this character 1. Doesn't really matter. And so now that we have that done, I'll go to I have this open and I have my downloads folder open still. And so since I saved it there, just drag character 1 into my defold. And while we're at it, I'll just make another stump. I wasn't planning on it, so just go paint again. And I'll scroll in one more time. And we'll make a ring like this. And now we can drag the ring. And then we'll make another ring a little bit smaller. We'll drag that inside. And then we'll drag the paint bucket. And we'll get like, we can just do red on the outside and a brown on the inside. Go to layers again. Hide this layer. The reason I'm hiding the layer is to make the background of this area basically fully alpha, I guess you would call it. And we'll file save. Save it back in the downloads. We'll call it tree. And now you have your tree and your player. So now we're ready to create our pathfinding script. So what we're going to do here, I'll close this. And then we have our characters. We need to make one more for resources. So we go a new folder, call it resources. And then in resources, we'll open this in desktop, and then we'll be done going back and forth between this and desktop. So we'll just drag our tree. If I can actually grab it. Drag our tree in there. And now we can close both of these. Now we have all our assets loaded into the game. Now for character, we have our character 1 PNG, and we're gonna need a new atlas. We'll just call this character 1 atlas, and then we'll add a image to our atlas. We'll just make it character 1 PNG. And now our character is in the world, or not in the world yet, but our character is set up. We'll file save all. And then we'll go back to, we'll close our world tile source, and we can close our character atlas, make a new game object. And this one we'll just call this people, because we might add multiple game objects under here, but for right now this will be our main game object. We'll add components, sprite, and the sprite's going to need an image, and that image will be our atlas. Default animation will just be the character. And see, our character is loaded into the world. We're going to set the Z position to, we want to go to people, and we'll set our Z position to 1. Make sure you use the game object attached, or the main game object for that, over anything else. And so we'll take our people and we'll scale him down just so he's not so big. Alright, now we have our person in the world. Now we'll go to resources and do the same thing for our resource, which is just going to be another atlas. If I can get my brain around it. We'll call this tree. And now we have our tree atlas. We'll set our image, set to tree.png, and that's all good and done. We'll close our atlas now. And now we'll add one more game object. We'll call this resources. And under our resources, since we're going to have multiple resources, we know that for sure. With our people, we might just create a factory underneath. That would be something to go over. So we'll add another game object, and we'll call this tree. And then we'll add a component. This will be a sprite. Our sprite's going to be our tree atlas. And default animation will be tree. And we can scale our tree down as well. We'll go for the game object, scale down the tree. Yeah, that looks about right. We'll set our position for the game object to 1, and then we'll move it into the world somewhere. We'll put it right here. That looks fine to me. All right, so now we have our character, our resource, and our world. One last thing we might want to do, so if we control build, you'll see why I'm about to do this. And our stuff is not centered. So the first thing I want to, or the next thing I want to do is add one more game object. We're gonna call this camera. And since the past year or two for Defold, camera is automatically attached. You never have to write a script anymore to attach it. You're gonna have to write scripts if you wanted to move it with your mouse or something like that. But otherwise, you should be fine. So we'll attach camera. Control build again. It's not going to show anything. So we'll go to orthographic projection. We'll go to 3D. And if you control click, left click, you'll see where the location of our camera is. The reason I put it on a game object is to do this. So I can actually move the camera. Otherwise you can't. If you just attach it to something, you can only move it in terms of the game object. So if we control build again, now we see everything, and that's all fine and dandy. We'll go to 1.8 on the zoom. It's gonna zoom in, and we'll just go back down to 1.4. See how that goes. Yeah, that's getting better. We'll go to 2D, and we'll change our camera location to be more centered on the character. All right, now we'll zoom back in a little bit more. 0.2. Or we'll go 1.8, sorry. And we'll send it to 2. Yeah, that's good enough for now. We can also we'll just go 2.5. All right, that looks good. And so now we're going to go to our people. We'll pull them down a little bit just so we'll just take our camera down just a tad. Just get it a little bit more centered in our screen. So everything looks good. Now we need a script. So I'm going to make it a character script since it's going to be controlling the character. Go to new script. And we'll just go character. And we're just going to delete everything. Control A, delete. And now that you have that done, we will grab our script. I copied most of it here. So I'm going to create this function. I'm just going to walk through it as I put it in. So, all right, you have a function, draw a line. This is going to message.post to the renderer, which is going to be the screen camera, is going to be our main renderer, I guess, basically now, since we added a camera into the world. Otherwise it would just be the window. So we're going to start point from We're going to go from our character, and we're going to draw a line from our character to the object, and we're going to need collisions on to do this drawing. So we're going to initialize our script in general. So we're going to acquire input focus. This, not sure if this is necessary since we're not going to have any inputs yet, but you will need this later on when we're sending commands to the character. And then self.speed, this is going to be our speed factor, so you can change this to change how fast the character travels to the along the path that we create. All right, so we'll backspace that. We'll go enter, and now we're going to start our update script. So you're just going to need function update, so we'll copy that in there. Function update self.dt and at the end of the function script. And the first thing we're going to put in is we don't need that. We're going to need from and to so that we can actually use our render draw line, which is a built-in function. And we're going to need the start point from and the endpoint to. So we'll put it in here. We got our go.getWorldPosition, and what this is going to do is get the position of this script, which will be attached to the character. And then we're going to get the local to, which is going to get the world position of tree. So in our main collection, we just gotta make sure that our game object is named tree. And if it's a game object itself that you're referencing and not the sprite, so I'll show you here. So the ID will be tree, and well, the ID will be the name that you give it, but the URL, which is what you're gonna need to reference stuff. So if we want to check the sprite location, we're gonna need tree hashtag sprite. But we're keeping the sprite attached to our game object, which will mean that we can just reference the game object itself with just quotation marks and tree. All right, so now next we're going to create a raycast. So we're going to store it in local result so that we can print this later. So we'll just pp print result. And since we have that, we can actually, what's up, CO? I forgot how I set it up earlier, but I mean, just Control C. And since this is named resources, this will work. I will go to the character script, and I'm in the wrong thing. So we need Control V, hash resources. So when we reference it in a list like this, we're going to need hash in front of the game object's name to, I don't know how to best explain it. I've probably explained it before, but I've not been using Defold a lot lately. So hash resources will be our everything under the game object. Anything under here will be able to find. So, all right, so that'll be our collision object that we're looking for, CO. That's stored in the local variable CO. So let's just control build, and I'm going to talk through essentially why nothing's happening. So to CO, we have no collisions, so there won't be any result here, even though we printed result. Let's build it again. I feel like that should be null. Anyways, moving forward, we'll go to character. Oh, I'll tell you why it's printing nothing, because we haven't attached it to our character. So go here, hit add component file and character script. Now I control build, control B, build. All right, so it is printing nil like I expected it to. That's because we have no collisions. So next what we need to do is we need to go to our resources, and this is going to work a little bit different than other collisions. You don't need to have a collision object on your player since you are raycasting, but you do need to have him set as a mask. So we go to add component, collision object, and then we'll add to our collision object, we'll add a shape, box. That's fine. Collision object, we'll call this group resources, and then our mask will be people. And now you see that our tree is falling, and I'll tell you why that is. We created a collision object on it, and it was dynamic. So dynamic's going to be affected by gravity. See, you have a mask right here. So it will be affected by gravity. So we're going to switch to kinematic. And this is going to be, things are going to stay where they are, is the best way to say it. But if they do bump into each other, they will be, if one is moving and it bumps into the other one, it will be registered. So we'll control build again. That's fixed. We get this. This is our result from our raycast. It tells us the position of the other object, and then it tells you the normal, which is going to be basically the longest side. If you draw the vector and then you draw the triangle for the vector, it will get the longest side. So if there's more y distance to cover than there is x distance to cover, y will be the vector, essentially, is how that works. All right, so, or the normal part. So like the normal will not be 0 in the y direction since the y is longer than the x here. Just barely, it looks like. Um, so moving on, we will go back into our character script. And so we have our results from our raycast. And now we need to have Control C. We'll go, if there's a result, we'll draw a line from to the result position. And we'll just go end here. All right, now we have our line. It's drawn from a character at the end position. And now we want to actually have our character follow this path. So it won't be perfect because, like I was talking about earlier, there's a difference between when the X and the Y get too close to being the same length, they will bounce between each other. So we'll start by going this way. So if the Y is greater, it'll go up a little bit, and then we'll follow the line. And it'll kind of bounce along that line. You can do things to smooth it out. Like I said, you can do something to take priority, so be more of a over, up type movement. So that's what we're getting at here. So let's go back to here. We'll print the next thing. We'll go, result. Well, we don't need the distance 2 yet. I'm just going to explain it as I go. We'll add things. Control C. File. I'll just undo whatever I just did. So we'll Control C this. Put this in here. I will put my script down below just so you can copy it if you need to. So Control V. If the result equals hash tree, we need a little slash in here because of the path, and we're not referencing an object attached to our object. So you see the URL will be /tree, and if we look down here in the ID, we see /tree. So everything in here needs to go in your hash. So, and we'll go result.id. ID will get us the ID right here. If you want the group, .group, .normal, .fraction, .position. And then we'll go self.direction. vmath.vector3 result normal. So we're going to set the normal as our direction. So whichever the longest side is, that's the direction. We will have a little bit of zig and zagging going on. So that's why this is the reason why it gets caught in that little back and forth that I was talking about, is because the normal is going to be flip-flopping, and that's what's going to cause a little bit of that. But in one of my later videos, we might go back and fix that. I fixed that in one of my other tutorials when we were talking about a chase script. So get the new position. This is going to be, we're going to calculate it. We got our position, we're going to get the character's position, we're going to get their speed, and we're going to multiply it by the direction. So our speed is just one factor, 100, and it'll be multiplied by each part of the vector, the x, y, and z, which we won't have a z because we don't want to move in that direction. But since both of our character and our object are on the same, so we got people is on 1, and we got our tree is also on 1, which is good. Make sure your resource is on 0 if your tree is going to be on 1. Otherwise, your tree will be on 2 if your resource is on 1 as well. So we go back to the script, and now we need to actually move our character. So we'll go dot set position to our new position. And the DT is the time, so it's basically, it's going to do this every tick. So if it's only a fraction of a second, it'll only move a fraction of the direction, essentially. And so now we get go dot set our new position, and let's see. I need an end, my bad. Alright, so we got a player move to the tree. We'll go to 50. It's a little bit fast on this world. Alright, you see this little zigzag. That's just the normal flopping. If we go back up into where it first starts, you'll see -1, 1, 1, 1, 1, -1, -1, 1. Basically, they're just flip-flopping because the distance is almost equal in both directions. So now we have that. If I move my character, we can actually see that more be smoothed out. So if we kind of make one side a lot longer than the other, he'll fix. And then it'll just be when we close, once those things become equal, then he'll close that distance. Go back to our character. Now we need to pick up the tree. We're not going to create an inventory in this video. I did make an inventory in one of my general default tutorials, so you can go check that out if you need to know that now or you don't have an idea where to start. So we have else if distance 2 is less than or equal to 60, and we'll grab the tree. So we'll add this into here. We can just control V. Now we need our variable distance 2. So we have this distance 2, and we're just going to create a vector from, I don't know if this is necessary right here. I'm not sure of the general output of this thing, so I just did this to be sure. So vmath dot length from -2, so we just get where we are to the distance to where the tree is located, and we check basically the distance between us and the tree, and we just say if it's less than 60, because you'll start getting this message. Otherwise, it's because the raycasting can't cast because the character is too close to the tree. So, or it's right on top of where the tree location is, so it's basically doesn't exist. The raycast doesn't exist at all. As you can see that the line disappears when we get too close. So I think the distance to what you can do to check what your distance needs to be on top of the tree. We'll go through the errors. So we'll see, we'll just print distance 2. That'll be faster, probably. So pb print, we'll go dist2. All right. Now we scroll up and grab the last distance too. So we go 9.5, 7, 6, 5. So you should probably set it to around 7, 6 or 7. Depends on your world. My last one was 60 in the example I showed. So we'll go distance to 7. We'll go 60, sorry. I'm in the wrong one again. So distance 2 will be 6 or 7. If it's less than or equal to 7, we'll grab the tree. So we'll go up to here, and we should be good. So let's see what happens. So let's go to 15. Just kind of double it and see what happens. It should be posting to the tree to disable. All right, so our distance 2, we are printing that out. Get rid of this thing. All right, so our distance didn't get that close before we started throwing errors. Maybe we did. No, that was our last trial run. So let's go 40. Just to make sure that our tree disables properly. Let's go 100. All right, well, maybe okay, I know what's going on here. All right, we'll go back down to 7. And then we'll say, and we'll say this and greater equal than 7, this 2. All right, now we grab the tree. We destroyed the tree. Next video, I will show you how to create a collision script here and get rid of the tree. And then we're going to talk about, path finding. So once he picks up the tree, what does he do with it? Does he put it in a storage? Does he put it in the shop and go to the shop and do something with it? And we'll set up that script next time. Thanks for watching. Hopefully this helped you a little bit. If you need any other help, just look at the documentation. The Defold people are great about that. So I will see you in my next video.